Sorry, just a second. I'm just waiting for the recording message to pop up. Oh yeah. Okay, there it is. All right. So string based in Bash, strings are basically the only type that you have. So all information is stored as a string, which means there has to be some way to manipulate strings. Otherwise, why bother storing everything in a string? So it turns out there's a few ways, well, more than a few ways. There's several ways to manipulate strings. The tr command is one of those ways. So tr is a command that lets you translate, squeeze, and or delete characters from a string. From standard input writing to standard output. So tr is more or less character-based search and replace for strings. So that's more or less what it does. The command is tr. You can use. There are some options which you can use. This string from, that's the set of characters to convert from, and to is the set of characters to convert to. So that's a little confusing when you see the command like this on its own. Instead, it's much more useful to see an example. All right, so remember, tr is going to read from standard input. So I need some way to get a string into this command. One way I can do that is to echo the string and then pipe it to the input of tr. Now, these are the characters that you want to translate from. Right? So this is saying I want to replace the p. These are the characters that you want to translate to. So I want to translate p to t. Right? And so in other words, I want to replace that with a t, and that with a t, that with a t, that with a t, that with a t. Right? So translate will translate all occurrences of a character from this set, corresponding character in this set. Type that. Oh, sorry, I don't have. Give me 1 second here. I don't have a terminal up. So if we type in that little example, I'm hoping it's going to let me cut and paste, but I don't know if it's going to do. Let's see if I can do this. Convinced this is going to work, but let's see. Yeah. Oh, it worked. Okay, good. So you can see that it replaces every p in that string with a t, right? So sparring with the purple porpoise becomes starring with the turtle tortoise. If you want to translate, oh, this is a good example here. So you be careful with this one. So you might be tempted to use this for assignment 2. There's a question in there where you have to take a package, a fully qualified package name, and convert it into directories. You can do it this way. You can get the directory this way, but you can't do one part of the question this way. But you can certainly create the directory structure for this package. Right. So in Java, if you've got a package, if you have a class in a package, right? So I have some class in the CA QueensU CS6124 package. Then the Java compiler expects the directory structure to be CA/QueensU/CS/sys124. Then the Java source code file is supposed to be in that directory there. So if you want to translate a package name or a fully qualified package name into a directory name, you can use tr. Translate every period to a slash. Now notice here, the period and the slash, they're not special inside of these strings, right? Inside of the single quoted strings. So that will give you CA/QueensU/CS/sys124. All right, now that's just single character replacement, which is useful, right? But if you want to replace multiple characters at the same time, then tr will also do that. So from and to are allowed to have more than one character in them. And in fact, they can be, they can take, those strings can, or those sets can take on several different forms. Right, so you can actually type in all the characters you want to translate from and to. right? So you can type in A through Z, right? Or little a through little z, right? Or 0 through 9. You can type them all in if you want to. If you want, you can use a range, right? Notice that this is not portable across all shells or operating systems. Right? Some versions of Unix and some other shells that are not Bash don't necessarily allow this syntax, right? But Bash does. So instead of typing in all that, you can write A hyphen Z. Right? Little a through Z would be little a hyphen Z. 0 through 9 would be 0 hyphen 9. POSIX character classes on any POSIX compliant system or almost POSIX compliant system. You can use the POSIX character classes, which we've seen already before. And so this is more or less, this is basically any Linux, Mac OS, any Unix you can use the character classes on. And so the character classes are also a little easier to read. They're harder to type, but they're easier to read. Right. So for example, that is equivalent to that. Right. So this is the class of all uppercase English letters. Lowercase, so lower would be lower. I think there's a digit, which is all digits. There's blank, which is the space and tab, I think. And then there's space, and there's a few others. But you can easily find out what these are. You just have to search for them. Now, usually the sets from and to, they have the same size, right? And if that's the case, then the way TR works is it takes the ith character in from and replaces it with the ith character in to, right? So it reads its input. Every time it sees a character in from, it replaces it with the corresponding character in to. For example, if I want to convert that string to all caps, then I can use TR to do that. Right? So I convert every lowercase letter to its corresponding uppercase letter. Right? And there's lots of different ways you can write that. You can write the two sets in this command. Again, we're going to echo. Now remember, the reason we're echoing here is because TR reads standard input. So I need to get something. I need to pipe the output from echo to the standard input of TR. A through Z, and then big A. Right, and that gives you CISC, capital all caps CISC 220. Right. You can of course reverse the two sets, so you can go from all uppercase to lowercase. I guess we should look at this. Obviously, if there's nothing in, right, if your input string doesn't contain any of those characters, then nothing happens, right? You just get 220. Right? If from is shorter than 2, then the excess characters of 2 are ignored. Right? So, for example, if we, in our previous example, so this is going to translate all letters from A through Z. Right? Now, suppose we only want to, we only convert, the to string only goes up to M. Right? Then that's interesting. The S gets replaced incorrectly. Oh, wait, if from is shorter than 2, then the excess characters of 2. Oh, if from is shorter than 2, sorry, reading it backwards. A through M, and then A through Z, right? So this will only convert the characters A through M, right? So in other words, the S is not going to be converted. Right? So that behaves the way you expect. If from is longer than 2, so that's the one I typed in incorrectly, then 2 is extended by copying its last character until 2 is the same length as from, which is interesting, right? This is not portable across different shells or operating systems, so this doesn't work reliably in different shells or operating systems. And you can see here that something bizarre happened in the previous example. Right? So in this example, from is longer than 2. So according to what I just wrote, oh wait, am I typing this in right? Sorry, hang on just a second here. I think I'm typing these, oh yeah, these examples are correct. My apologies. This should have been. Let's try it out. Oh yeah, that's better. That's what I was expecting to get. All right. So in this example here, we're going to map the characters A through Z, right, onto the characters A through M. Now the problem is the characters N through Z are missing from here, so the M is duplicated, so that this set is the same length as this set here, which is why the S gets replaced with an M. Now it got replaced with a closing right bracket because when I wrote that, this is mapping that bracket to that bracket. It's mapping that bracket to that bracket. Right now, this set is shorter than this set, so the last character of this set gets extended. Right, so that that closing square bracket gets extended, which is why you get the the square bracket here. Let me go back and fix these to what they should be. Okay, that's better. And here, that. And this is interesting. So I'm not exactly sure what's going to happen in that one. Okay, so here's another example. If you want to convert all the digits to X, right? So, or a star or something like that, right? Where you might see that in a password or something like that. Then again, you can use TR to do this, right? So I'm going to convert all the digits 0 through 9 to the letter X in this case. That 9, and I'm going to go to X, and you get that. Apparently, so if you want to do this portably, then this is the better way to do it. Right, so use the POSIX character class digit, and then the star tells TR explicitly to extend this to the same length as this. That's what the star means in this case. Right, so this one is, I'm pretty sure this is guaranteed to work on all POSIX compliant systems. We're in Bash though, so this is fine for our purposes. Right, now these are supposed to be sets of characters. Now the interesting thing about TR is that it doesn't actually check if from and to are sets, right? So it doesn't actually check if there's any duplicated characters. And in fact, the way the Bash version works is it makes sure that the second quote unquote set has the same length as the first set by extending that character. So in fact, this is not it's not a true set, right? So if from contains duplicated characters, the result is undefined, which means anything can happen. Right? So here our from is has a duplicated C. Right? I actually don't know what happens in this example, so let's run it and see what happens. So I'm going to convert CISC to CIS. Let's see what it does. Right. So the question is what does it do with that C there? And the answer is, okay. Apparently actually, this is extra interesting. All right, so what's going to happen? So what happens here? So it looks like my version of Bash is going to extend this string so that it's the same length as this string. Right, so in other words, it's going to do this. And then it looks like when it does the translation, right, it doesn't replace it with that character. It ends up replacing it with whatever the last C maps to, which is the capital S. The very unusual SISS220 here. Right. This is basically telling you don't do this. Right. So make sure that from does not contain duplicated characters. Whenever you see, so you're going to see this phrase a lot when we start to talk about C, right? You're going to see the phrase is undefined over and over and over again because the C programming language standard is written that way, right? If blah, 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 then the result is undefined. Now the problem is with undefined, right? It means that whoever is implementing the C compiler, or in this case, whoever is implementing TR for your particular shell, is allowed to do whatever they want. So in this case, we ended up with CISS 220, right? But another completely reasonable result, right, would have been CISS 220, right? Or even possibly CISC 220, if that second C maps to whatever the first C mapped to, right? So the problem with this undefined behavior is you can get stuff to work until you move it to another operating system or to another platform, and then everything blows up on you. So whenever you see this phrase is undefined, avoid doing whatever is undefined, because you have no guarantee that what works today is going to work tomorrow. Okay, TR can also delete characters using the set from, right? So if you use the -D option, that tells TR to delete whatever characters are in the set from in the string that you provide TR. Here I've got the date 2021-10/04, and I want to delete all the hyphens, right? That's going to give me 2021-10/04, right, with no hyphens in it. Worth typing in. We can use today's date instead. 08. Sorry, 09. TR -D, and then I want to replace the hyphens. Right. So that deletes all occurrences of the hyphen from the string. Right. You can delete all occurrences of the hyphen and 0 if you wanted to. Whoops, sorry, invalid option. Like that, right? Out it goes. The hyphen is interesting, right? Now remember, the hyphen is used to indicate a range, right? So you have to be a little bit careful when you use it. Does this work? Yeah, that works. Okay. So the location of the hyphen, if you want to delete a hyphen from a string, you have to be careful where you put it. Apparently, in my implementation of TR, you can't put it at the front, but you can put it at the end. Squeezing repeated characters. -S will remove repeated sequences of characters, but it'll leave you with the first character that was repeated. Right. So if you have A, and you squeeze out the A's, you'll get a single A. So this is a good example. Let's run that and see exactly how it treats it. So a bunch of A's, then a bunch of B's, and then a bunch of C's. B's, right, -S, right? All right, so let's see what we get, right? We're going to squeeze out all the A's and then all the B's, right? So all the A's get compressed down to a single A, right? All the B's get compressed down to a single B, and then we're left with the 3 C's. Okay. Now the next one, A, B, A, B, A, B. So when we do that, nothing happens, right? So it's squeezing single characters, right? So it's not squeezing sequences, right? So here, if you wanted to get if you wanted to get rid of the A, B, then you can't use it with TR. You can't do it using TR, right? So in this case, it's going to squeeze all repeated runs of A's, all repeated runs of B's, right? And there are no repeated runs of A's or B's. Single A, single B, single A, single B. Okay, so there's TR. Now there's a bunch of expansion. So these are a bunch of ways that you can handle empty variables. I just want to quickly, hang on, just give me a second. I just want to jump ahead to see if, to check if I'm doing something here. Substring. Okay, so we're going to do the substring stuff later. Now, a lot of the time in Bash, you end up with empty variables, right? So you end up with a variable that's not defined, right? So imagine you have a script. It's supposed to take in 1 or more command line arguments, right? But whoever's using the script is able to call it without command line arguments. Right now, in that case, so if you do something like, I don't know, like arg1 equals $1 to get the first argument, and the caller hasn't provided any command line arguments, then arg1 exists, but it's empty. Right? It exists because bash makes the variable for you when you say arg1 equals something. $1 doesn't exist, right? So the positional parameter $1 doesn't exist if the caller does not pass in a command line argument. So you end up with an empty variable, which is inconvenient. So bash provides you with a way to handle those empty variables. And it doesn't provide you with one way, it provides you with four different ways to do this. So we'll have to go through these one at a time. Okay, when you see the word parameter in bash, that just means variable. Here we've got $brace parameter, so variable colon minus word. This results in the string parameter if parameter is set, right? So if you have a variable with this name here, right, then nothing happens. Okay, so nothing happens. So that's good, right? If the parameter is unset or empty, right, then you end up with whatever word is, right? But this does not assign a value to parameter. So these are all listed in order, but let's jump ahead and look at the example. Okay. So here I've got foo equals nothing. So foo's not set, right? I'm then going to use this substitution to get the word substitute in this case, right? So foo's not set, right? So all of this evaluates to whatever this string is here. That's going to echo out substitute, right? Now what this doesn't do, this does not set the value of foo. It doesn't set the value of foo, so foo's still empty. So we do foo equals nothing, right? Then we echo out. I'm just going to write in subs because it's shorter, right? You get the string subs, right? So this, in other words, this evaluates to whatever that is, right? But it does not affect the variable foo, right? So foo's still empty. Oh, sorry. Now, if foo is set, right? So foo is now equal to bar, right? So now if I do this, right? Foo is set, so this evaluates to foo, right? Which is bar. This is going to just print out bar, right? And again, it doesn't change the value of foo. There we go. So that's the first version, right? So that's what the minus sign does. Okay, now there's an equal. So if you change that hyphen to equals, right, then it does the same thing. So if that's set, nothing happens, right? If this is unset or empty, right, the result is word, right? But word is now assigned to your parameter. So here. So same example again. So let's set foo to nothing. Right, then let's do the substitution, except this time we're going to change minus to equals. Right, so this should evaluate to subs because foo is empty. It does, right? And it should have also assigned subs to foo. Now, if foo is already set, nothing happens, right? So if foo is already bar, then this substitution evaluates to foo, and foo is not affected, right? So foo is unchanged. All right, that's 2 of the 4. Question mark word. Okay. Okay, so if that's not set, sorry, if this is set, nothing happens. If it's not set, or if it's empty, then you get an error, right? And it sends that word to standard error, right? So this is this is one way that you can print an error message to standard error. So if your program, so if your script expects a command line argument and someone doesn't give it to you, this would be one way to tell. This would be one way to print out an error message to indicate that the expected command line argument is missing. So here's the example. Again, foo is empty. Right, so this should evaluate to whatever this message is here. And it should send this to standard error. So you get an error message, right? So it's not a great error message, right? So in particular, it's not it's not super informative unless you know how the error message was generated, right? But it's trying to tell you that foo was unset, right? And it prints this message instead. It doesn't change the value of foo though, so that's still empty. Now, did this actually go to standard error, right? So how do you tell that actually went to standard error, right? The answer is you redirect standard error. Do I redirect to standard error again? Redirect. Oh, sorry, I forget how to redirect to standard error. Anybody know off the top of your head? Redirect to. It's funny because I was just doing this for assignment 2. Oh, sorry, I'm doing the wrong thing. I want to redirect standard error to a file. I'm sorry. That's what I want to redirect standard error to a file. Nope. I want to do to error.txt. There we go. Oh, this is a little embarrassing. Yeah, that's not here. This is right, isn't it? Or not? Well, I can redirect it to standard out, but I don't really want to do that. I can do that. Does the same thing. All right, we'll have to look it up later. Anyway, so to check that this actually went to standard error, just redirect standard error to a file, and then check if it's in, and then look at the file to see, and then look in the file. Right? You shouldn't get any error. You shouldn't get anything printed to the console. Last one, the plus, results in nothing if the parameter is unset or empty. So if this is unset or empty, nothing happens, which is interesting, right? Now, if it is set, then that gets substituted for whatever that is, right? But the value of the parameter is not changed. This one's a bit unusual in its to use. But we try it out, see what happens. Right. So again, foo is not set. Nothing should happen here, right? If I'm using the plus, because foo is unset, so nothing should happen here, and nothing does, right? Nothing should happen to foo. Now, if foo is set, and we do this, right, you should get that. Right? So we should get subs in this case, but again, foo is untouched. So foo doesn't change in this case. So there are the 4 ways to handle an unset variable. There's other ways to do it too, right? So you can always check using an if statement. So if none of these do what you want to do, and in many cases, these don't do what you want it to do, right? You can use an if statement to check if a variable is empty, right? So if square bracket minus minus Z, we'll check if a string is empty. Then you can do something else, right? So do whatever you need to do to in the case where a variable has not been set. If you want to find the length of a string, it's the pound sign again, right? Followed by the name of the variable. Okay, so dollar, brace, pound, variable name expands to the length of the string stored in the parameter. Okay. If parameter is at or star, then the expansion results in the number of positional parameters. So we saw that earlier, right? If you want to know how many command line arguments are given, you can do dollar, pound, and then at, or dollar, pound, star. There's the string hello, right? How long is hello? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you actually run that, you should get 12. Equals L. Dollar. Now that doesn't, so if you want to do something with the individual letters of the string, right, if you want to loop over the individual characters, right, then getting the number of characters helps. Right? Now you need to be able to get the individual characters from a string, so that's when you use the substring notation. So variable name, colon, offset, that gives you the substring of whatever this variable is, starting at that index, right? And the index is 0 based, right? So if that's a 0, this gives you the whole string, right? If that's a 1, then this gives you whatever string is here, not including the first character, right? And so on and so forth, right? You have to be careful with this because this sort of looks like Python, but it's not, right? So variable name, right? That's your starting index. And now, unlike Python, this is the length, right? So it's not the end index minus 1, right? Sorry, it's not the end index plus 1, which it is in Python. The length of the substring. That expands to the, yeah, there we go. Right, so if you want to get a single character from a string, that's always 1. Right, substring length. S is the string. Don't really need the quotes in this case. Don't need the quotes because there's no spaces in the string S, so this should be fine. Right. This is the substring starting at index 0, going to the end of the string, right? So that's just S. Okay. The substring starting at index 1, going to the end of the string. So that starts at B, and then one more time, right? This is the substring starting at the character at index 2. Right, so that's going to be C, D, E, F, G, up to J. And now using using an index followed by the length, right? So that's the string starting at index 0. That's too long, right? So that's going to be AB, right? If you want a single character, it's always the 1. That's the last character, as the last for the length, right? I don't know what happens if you put in 0. You don't get an error, and apparently you get the empty string. 0. So I guess we'll try. I mean, 0 is not that interesting. Let's do 3 and then 2. So this will be the string starting at index 3. So 0, 1, 2, 3. So D. This should be DE. And it is. So that's how you get a substring from a string in Bash. If you want to remove the leading part of a string, then you can use the, I guess the hashtag or the pound symbol or the double hashtag or double pound symbol, followed by a pattern. So this syntax here removes the shortest leading part of the string that matches that. This lets you remove a substring. This lets you remove the substring from a front of a string. Right? So you specify the thing that you want to remove. That's at the front of the string, and this will remove it. Right? So that removes the shortest leading part of the string that matches the pattern. Right? If you use two hashtags, that's going to remove the longest leading part of the string that matches the pattern. All right, so here we go. I've got a string file.text, right? Want to remove. So there's my string name. There's the hashtag. Now there's the star, right? So the star matches anything in this case. In this context, right? Star matches anything. Do I have these listed somewhere? Okay, so star. The star here is the same as the star that you use as a wildcard for for path name expansion. So that star there matches anything, right? And then followed by a dot. Anything followed by a dot. So it's going to replace, now there's only one pound sign here, so it's going to replace the shortest string at the front that matches that pattern, right? So in other words, it's going to replace file dot in this case. So pound star dot. The .txt, so this gives you the extension in this case. Right. Now, if you use the double pound sign in this case, you're going to get the exact same answer. The difference occurs when you have a different file name. So if you have a file name, that's file.text.zip. So now this one has the extension zip. The base name of the file is file.text. So this version, where there's a single pound sign, removes the shortest leading part of the string that matches star dot. So it's going to replace the file dot, right? The shortest part. Text.zip. If you really want to get the extension in this case, you have to use the double pound sign, right? Now this will replace the remove the longest leading part of the string that matches the pattern. Right? So that gives you the zip in this case. Right? So that's this is how you get. This is one way to get the extension from the file name. So if you can remove the leading part, you can also remove the trailing part. Right? So you can remove the shortest part of a string, the shortest part at the end of a string that matches that, or you can remove the longest part at the end of the string that matches that. So here, now I want to remove the extension to get what's called the base name of a file name. To do that, I want to remove everything at the end, right? That's after the period and including the period. Right? So I want to strip off the, so in this case, I can use the pattern dot star, right? Matches that, followed by text. Let me clear that. Dot and star. So that's going to give you file, which is good, right? Again, because there's only one thing at the end of the string that matches dot star, this will give you the exact same answer. Okay. So again, it's not until you change the name of the file so that it has more than one period in it, do you get a different answer. Now, when I remove the shortest part at the end of the string that matches dot star, it's going to remove the dot zip. File.text. If you really want to get rid of all of these things, then you need to use double percent sign. Get file. Replacing stuff. So you can replace a substring, again, using a wildcard-based pattern, right? You don't have to use wildcard-based patterns either. I guess I should, right? So there doesn't have to be a wildcard in the replacement. Right? So if we, again, so if we, that, right? If you happen to know that the extension's .zip, then you can just, you don't have to use .star, you can use .zip, right? And that will get rid of, we only need one, right? That'll give you file.txt, right? So you can use star and question mark in the pattern, but you don't have to. There's no reason that you have to use that. To do string replacement, it's this funny syntax that looks like this, right? So it's a slash, then the pattern, slash, and then the replacement string, right? So that there is the replacement string, right? That's the pattern that'll match, right? Now this replaces the first substring that matches that pattern, right? Slash, slash, before the pattern replaces all substrings that match the pattern, right? Unfortunately, it's not slash, slash here and slash, slash here, right? It's only notice that, so in all these examples, right, the only difference in the strings are like one character, right? So here it's double slash, here it's double %sign, right? Here it's double pound, right? So you have to be very careful when you're using these that you use the right one, because it's very easy to use the wrong one, and then it's hard to find. Right? Because I mean, honestly, this does not look a lot different than this. Right? Similarly, that does not look a lot different than that. When you're debugging your bash scripts, stuff like this. Okay, so I can do, instead of using tr, I can just use the string replacement, the substring replacement syntax. Right, so this is the tr example where we replaced every p with a, this is the one that replaces every p with a t. Because there's only a single slash here, this is only going to replace the first p with a t. So that'll get replaced with a t, everything else will stay the same. And echo s slash p slash. Only the first t gets replaced, right? S doesn't get changed, right? So this returns a new string. So if you echo back s, s is still the original string, right? So this is sort of like, I guess this is closer to, no, Java and Python are both the same. Strings are immutable. So in this case, you're getting back a new string, right? You're not modifying the original string. Okay. If you want to modify the original string, you have to reassign the value back to the string. Use the double slash, right? Now you get every p replaced with a t, right? And again, the original string is still unchanged. If string is omitted, then deletion occurs, right? So this is like using tr with -d. So let's do this one, like that. Okay. So that's going to remove the first p. So you get starring with a purple porpoise, right? Again, s is unchanged. You want to remove all the p's, then it's //p, slash, right? Don't forget the closing slash, right? And now you get starring with an Earl Oris, right? And s is still unchanged. Case conversion. So you can use tr to convert case, right? You can also use these one of these 4 substitutions, right, to perform case conversion. Right? So comma replaces returns back the value, whatever value is stored in here, in all lowercase. Single comma returns whatever string was is stored in this variable here, but replaces the first character with a lowercase character, right? Double caret turns everything into all caps. Single caret turns the first letter into all caps. lowercase, so we're starting out with a lowercase first letter. So comma, comma, replace, everything becomes lowercase. So the second C goes to lowercase. S is still unchanged. Replace only the first capital letter with a lowercase, with the corresponding lowercase letter. Oops, echo, sorry, I'm dumb. Replace the first letter in the string with the lowercase version. It's already lowercase, so nothing happens. Right. Comma, now to uppercase. Now everything will be turned to uppercase. Only the first letter in uppercase, right? And it leaves everything else unchanged. And in all the examples, S never gets changed. S always stays the same. Oh, that's it. Oh, and we're also at the end of the lecture now, so that's good. All right, so that's, I think that's all of the major string operations that Bash provides for you. Right, so the string manipulations, they're not as complete as, say, Java or Python, but they give you most of what you need to do. Right. There are more sophisticated tools too that can perform string conversions. Right. So in particular, there's tools sed and awk will be are able to do very complicated text conversions and text editing in general. But I don't think we're going to look at those tools in this version of the course. Okay. Any questions about string manipulation, I guess, in Bash? Okay. I'm not seeing any questions. So I guess I'll end that there. And we'll start the C stuff of the C part of the course on Friday. All right. So until then, oh, I do have office hours tomorrow if you need to talk to me about something. So those will be at 3:30, and the link is on OnQ Teams. All right. So that's everything for today, and I will see you on Friday. You're welcome, everybody.